Okay, Evan, yeah, you're here. Jocelyn, Susan, please raise your hand if you're here. Jocelyn, are you there? Okay. All right, so let's start with a new chapter now. Okay, so the next part is called trigonometry. As you can see, I have part one, right? Part one, that means this is a very long chapter, okay? Trigonometry is measuring the angles and has to do with triangles, okay? So we just quickly skim through what's inside. In part one, we will talk about angles, okay? How it's being measured, how to draw the angle in the proper ways, right? And then we have trig ratios. So it has to do with the SOHCAHTOA, if you remember from grade 10, sine, cosine, tangent, okay? So we'll be reviewing that, and then we'll be adding, other than SOHCAHTOA, we have 3 more. And then after that, we have something that you learn in grade 11, finding exact values, finding the angles. Okay, so most of it will be a review in the first part. And then we have trig functions. Okay, so as you can see, functions, that means you can graph. And when you see graph, then we need to apply what you learn in transformation. Right, transformation, we can do RST on any graph, right? Reflection, expand, compression, okay, we can apply to the trig graph. And then after that, right, that's the end of part one. Okay, so our main goal is to do graphing, okay, slowly get to graphs. And then part two, no more graph for part two. Okay, part two is more related to the equation. Okay, so we'll be looking at part two after that. So main thing in part one is to do some review first, and then do the graphing. Okay, because we haven't seen any graphing for the trig. So let's go back to page 34. So today's homework it will be much easier. Okay, because just introduction. We'll learn some easy changing of how to draw the angle and changing the measurements. Okay, so let's look at page 34 here. So we start with angles in standard position. Okay, standard position means it's like a standard way to draw the angle. So for example, when the question says, please draw a 120-degree angle, right? What does a 120-degree angle look like? Eric, can you try to draw on the screen? 120-degree angle. Yeah, 120-degree. Very good.
I think that might actually be a bit big because that'd be like, I think it's more, actually it's pretty similar, never mind.
Yeah, or something, it could be like that, right? 120-degree, right? Even is maybe some people, they will draw this way, 120-degree, right? So everybody will be drawing differently. So that's why it's not a standard way to draw it. We need to have a standard, put the angle in the standard position. So when you hand in your picture, everyone's will be the same. So why is it better to have the same rules? So we can communicate better, right? When we talk about left and right, everyone know which side is left, which side is right, right? Okay, Eric, can you help me clear the screen? Okay, thank you. Okay, so here, over here, we're gonna talk about how we draw the angle in a standard way. Okay, so this is called angles in standard position. So first of all, when you have an angle, it needs to have a starting place right? So we call that the initial arm. Okay, I'll highlight it here, initial, right? And there's a terminal arm where the angle stops. Okay, so it's like looking at the clock, the minute, the second hand, right? And you have the hour hand and also the minute hand. Okay, so it's like turning around the clock. So you always fix your starting arm on the positive x-axis. Okay, so positive side of the x-axis will be this one, the red one. Okay, so your beginning of the angle always starts from here, positive x-axis. And where you stop will be this one. We call that terminal, like terminator, right? Terminate, stopping. So your terminal arm, you always put it in any of the 4 quadrants. Okay, so 4 quadrants is talking about number 1, number 2, number 3, number 4. Okay, so it'll be turning, you can rest the angle in any of the 4 locations. Okay, like a clock. So for example, if it's in quadrant 1, right, quadrant 1, it will start from here and then stop there, right? So the angle that's there, it could be like 40 degree, right? 40 degree will be first quadrant. If it continues to turn, I keep on turning, turn to second quadrant, so the stopping there, right? So that could be the 120 degree, right? If I keep on turning it, for example, turn to there, what kind of angle will be like that? Evan, how big would that angle be? Possibly.
Which one?
The one on the top. The green one. Evan?
I'm not quite sure.
Okay. Did you understand the 2 example I said before?
The initial arm and the terminal arm one?
For example, if you start the angle here, right? You always start from angle from the red, right?
Yeah.
Okay. If it's okay, let me try to draw it this way. Use a straight line, right? So this is, you see the blue line is turning,
Yeah.
right? Like a clock. Okay. So if it turns to the first quadrant, this is less than 90 degree. You know how big is 90 degree, right?
Yeah.
90 degree will be up there. So if it's somewhere here, how big is that angle?
45.
Yeah, probably 45, right? If it turns to second quadrant, let's say there, how big is the angle?
Like 120.
Yeah, and then it keeps on turning to here. What would that be?
180.
Very good. So now if it stops in the third quadrant, what could that be?
Like 200.
Yeah, it could be 200. Okay, so that was my question, right? So this angle could be 200 degree. Make sense?
Yeah.
Okay. Right, now let me ask another person, right? So if it keeps on turning, here's the angle, keeps on turning and turn to the 4th quadrant. How big could that be, Jenny? Are you there?
Yeah.
Yeah.
Does
so
the other one? Does
Yeah.
the other one say 200?
Yeah, this one will be 200, right?
Mm-hmm.
If it keeps on turning to here, how big would that be?
It should be 290.
290. Okay. How about here? If it's right under.
Right under.
Yeah, like right here is 180 degree, right?
Mm-hmm.
Okay. If it turns to the bottom here, how big would that be?
270.
Yeah. If it's a full circle,
360.
yeah. Okay. So somewhere in between 270 and 360, you said what angle could this be?
Sorry, what's your question?
What angle does this one look like?
315.
315, sure. Okay. So anywhere between 270 and 360. Okay. So it could stop in any of the four quadrants. That's what I'm trying to say. So it can turn, right? Keep on turning. Even you could even get bigger than 360, right? If I make it even turn more than one turn, right? 90, 180, 270, 360, right? I turn more, right? You add another 90, I can keep on turning. So your angle will get bigger and bigger. So turning in this direction, okay, is called the counterclockwise, right? Look at the clock. You are turning this way. Okay, this is counterclockwise. So when you turn counterclockwise, then the angle will be positive. Okay, but you always start from the positive x-axis. Your initial arm doesn't change. Right, and then if you turn clockwise, like this way, the second picture here, this is clockwise. Your starting place is still there, right? Then that angle will be negative. So now you could have a positive angle, could be a negative angle, right? Depending on which way you're turning. So for example, let's say if counterclockwise it's 200 degrees, right? It's the same position, right? Same arm, same terminal arm. Then clockwise, how big is that angle then? Nick, what do you think? How big is the clockwise turning to the same place?
160.
How did you find that number?
Because like 300 degrees, 360 degrees minus 200.
Okay, 360 degree is the full circle, right? Yeah. Okay, so you take away the other part, left over will be the clockwise. Okay, so just remember some of the key points, right? 90 degree, 180 degree, 270, right? 360, those are the key landmark, okay? And then you can use that to figure out other angles. Okay, can you raise your hand if you understand everything up to here? So if the angle is placed in this way, we call it standard position, okay? So when I say, please draw, oh, I forgot the negative sign, right? So clockwise, please draw negative 45 degree. Then everyone should hand in the same picture, okay? Negative 45 degree, everyone should have the same. Daniel and Marcus, any questions?
No.
Okay, right. So let's try the question at the bottom. Okay, so please find the degree of the four standard position here. So two of them is turning more than one turn, right? So it will be more than 360. And pay attention to whether the angle is positive or negative. Okay, so raise your hand when you finish the angle, right? When you found the degree. So for the first picture, the 70 degree is talking about this little one, okay? But the one we are looking for is this one, the red one, okay? We're looking for that. Look at the arrow, okay? It tells you which way it turns. Okay, we'll go over question A first. Everyone should finish A at least. Susan, what's your answer for A?
290.
And how did you find that?
360 minus 70.
Very good. Positive or negative angle?
Positive.
Okay, yeah. So this one is counterclockwise, should be positive angle. So it turns almost a full circle, right? It's 70-degree away from full circle. So you need to take away 70. So think about pizza, right? You take away a slice of pizza that is 70-degree wide, right? So you're left with 290-degree. Okay, question B. Caleb, what's your answer for B?
Minus 300 and minus 335.
Okay, how did you find that number?
360 minus 25.
360 minus 25, but that will be positive though.
I mean, sorry, no. Minus 270 minus 25.
270? What do you mean?
I mean, actually, no, I'm not so sure.
Well, you got the answer right. How did you find that number? You got it right.
I'm not so sure. I just assumed.
Okay. Okay, if you look at the arrow, right? Is this gonna be positive or negative angle?
Oh, negative.
Negative, right? It's turning which way?
Oh, clockwise.
Clockwise, right? So we know it's a negative answer, but then it's almost a full circle, right? It's 25-degree away from full circle, right?
Mhm.
So we just take away 25-degree from 360 and have a negative at the front.
Okay.
Okay, if you want to show the step, this is what you can do. Okay. Yeah, Susan, of course. Okay, and then question C. All right, Angela, have you got question C yet?
Sorry, wait 1 second.
Yeah.
Is it 630?
Say that one more time.
630?
630. How did you find that?
360, and then you added, because that's like one circle, and you add 270.
Okay, very good. Okay, so make a full circle first, and we're not there yet. So we keep on adding a 3/4 of a circle. Okay, question D. Marcus,
I got negative 580.
okay, how did you find that?
Negative 360 minus negative negative 220.
Okay, so keep on going for 220, right?
Yeah.
Yeah, okay, so you can do, there are two ways to think about it. You can think about we are going negative, right? Negative direction, so negative 360, but we're not there yet. Keep subtracting, right? Subtract 220 degree more. That's one way to think about it. The other way is we put the negative later. We do 360 degree and then have another 220. And then we know the answer should be negative. We put the negative at the end. Okay, either way, right? So your answer should be a negative number. Okay, any questions? So Nick and Jocelyn, are you done?
Yes.
How about you, Jocelyn?
Yeah.
Yeah, okay, so you can raise your hand. Okay, let's move on to the next part. So right now we know how to draw the angle, right? And then the next part is talking about the angles in radian measure. Radian. So this is a new word, okay, maybe for some of you. Radian sounds like the word radius. So it has to do with radius. Measure, right? Measure means you measure the angle, right? So when you measure the angle, usually we use degree. And we've been using degrees since you ever start learning about angle, right? Perhaps you know about angle in grade 6, right? 90 degree, 180 degree. So measurement, right? For angle, now we are going to introduce a different way to measure the angle, okay? Measure the angle with different unit. Okay, so instead of degree, we have a different unit called the radian. So think about like for when you try to measure the height, right? The height of yourself. So Eric, how tall are you?
In centimeters or feet?
I don't know, whatever.
I think it's like 6'3".
So 6 feet.
6 foot 3 inches.
3 inches. Do you say that? 3 inches?
Yeah.
Okay. So if I change this, if I want to change this into let's say inches, how do you do that? Everything in inches. Eric, where are you? How do I?
You have to multiply the feet by something to get the inches. I'm not sure how much it is right now.
Can you find it? Can you find out how many inches in a foot?
12. So the answer would be 72.
Okay, so what did you do?
72 plus 3, so 75.
Okay, so times the 6 by 12, and then you add the 3 inches, right? So what's the total again?
75.
Yeah, 75 inches. So we have this one, and then you change it to inches, right? So you're changing foot to inch. So 1 foot is 12 inches. So this is helping you to change measurement, right? So for measuring the length, the height, you have these two kinds of units, right? Or you could use centimeter and changing to meters. Okay, so why not have different measurement for angle, right? We've been using degree for a long time. Okay, so this is what we are talking about here. We will have a different ways to measure these angles, and that way is by using the radius. Okay, and the benefit of using that is so you don't have the little circle, and you can work with length. Okay, because when you have a degree sign, right, with a little circle at the corner, you cannot take that to operate with other kinds of number. Okay, so let's look at the definition, how to measure a degree. How do we change, right, from degree to a radian? So if I give you a circle, right, with a radius of r, okay, so you look at the picture, we'll use a number, easier to understand, okay? So let's say the radius is, let's give it a number. Chris, can you pick a number for the radius?
3.
3, okay, so let's say the radius is 3 cm, 3 centimeter, okay? And then if the arc length is equal to the radius, okay, arc length is talking about this part, the curvy part. Okay, if that part is also 3 cm, right, equal to the radius, then the central angle theta, okay, the amount of the opening, right, of the angle at the center, we call that central angle. So this part is called 1 radian. We just write 1. So you don't put a little circle, okay? So 1 is different from 1 degree. Okay, on the left side, this is called 1 radian. This is 1 radian. This side is 1 degree. Okay, they're different. Okay, so the way you can see, I already put it here, right? The angle theta equals to 1 radian. Or you can just write 1, okay, without the little circle. Any questions so far? Okay, can you raise your hand once you got everything down here? So this is how you find 1 radian, okay? If you want to find 1 degree, you need to cut it into 360 parts, right? A full circle is 360 degrees. For 1 radian, right, it just make the arc length same as the radius, then the amount of opening, that's called 1 radian. Right, so please raise your hand when you finish writing these down, not too much, okay? Okay, so next part, we need to think about how is 1 radian related to 1 degree. All right, so by the look of it, 1 radian and 1 degree, which one looks bigger? Philip?
Degree?
Degree looks bigger?
No, radian.
Radian is wider, right?
Yeah.
Yeah, okay, 1 degree probably will look only like this. very tiny. Okay, this is 1 degree. One radian has to open wider because it has to be open as wide as your radius. Okay, so you can see it just by the picture. So we need to connect them. Okay, think about how they relate. Okay, just like we know 1 foot is 12 inch. So here we have 2 pictures here. The left side is for degree, right side is for radian. Okay, so for a full circle in radian, for degree, we know full circle is 360 degree. Okay, so write it down. Full circle. Okay. Now for this one, right? If radius, every time you put a radius, right, here's the radius. I put, so this is about the size, right? About maybe a bit shorter. Right, because it's bended, right? This is radius, and then this opening is 1. So if I want to turn a full circle, every radius will be 1. How many every 1 radian will be in a full circle then? Right, so we can use the 3 centimeter as our example, right? Let's say if it's 3 cm, how many 3 cm can fit on the circumference, right? Because every time you fit a 3, it will be called 1 radian. Okay, can anyone estimate around how many 3 I can fit around the circle? Approximately how many? Anybody? Daniel, what do you think? How many times you can fit this radius around the circumference?
Like 5 or 6.
Okay, so let's try it out, right? So this is the first one. Let's fit another one, right? This is another radius, right? Probably can fit another one, right? So far we got 1, 2, 3, 4, right? 5, 6, right? Probably a little bit more than 6, right? You can see that I divided equally. 1 radian, 2 radian, 3 radian, 4 radian, 5 radian, 6 radian, and then a little bit more. So we should expect around 6 point something radian for a full circle, okay? So to figure out exactly how many, we need to find out the circumference. How do we find circumference? What's the formula for finding circumference? Does anyone remember? Circumference?
2 pi r.
Yeah, very good. So 2 pi r, right? So in this example, our radius is 3. So it'll be 2 pi times 3. So that gives you 6 pi. Right? 6 pi is the circumference. I want to find out how many 3 can fit in there. Okay? Number of radius in the circumference. So how do I find out how many radius can fit into 6 pi? What should we do now? Sophie, what do you think? If I want to find out how many radius can fit into 6 pi?
You divide it by 3.
Yeah, very good. Okay, so it'll be 6 pi, that's our circumference divided by 3. So that will simplify into 2 pi. So that 2 pi is our radian for full circle. 2 pi, pi is 3.14, right? So 3.14 times 2 is what? 6.28, right? So about 6, just like what we predicted. A little bit more than 6, okay? So 360 degree will be 2 pi. Okay, this is the conversion factor connecting the full circle in degree with the full circle in radian. Just like when you have 1 foot, it's 12, right? You need to have something that with different unit, but they equal each other. Okay, so full circle in 360 in degree is 360. In radian is 2 pi. So now if you get half a circle, right? Half a circle. If the angle turns half a circle, so Jenny, what will be the degree?
I am not sure.
I don't know. Don't say you're not sure. You know it. Full circle, how many degree?
Oh, 360.
Half
I
a
do
circle.
know. 180?
Yeah, you know, right? Don't give up too fast. Okay. So go to radian. Okay, don't turn off your mic. Full circle in radian is 2 pi.
Mhm.
Half a circle will be
1 pi?
yeah, excellent, right? Very easy. So you start with a full circle. If you know full circle, you know how to get the other one. Okay, so let's try other one, right? So for example, instead of half a circle, let's say we have this. How many degree is this angle? The one that's shaded. Okay, Angela?
90.
Yeah. Okay, and what will be the radian for that?
Pi over 2.
Very good. You cut the pi in half again, just like 180, you cut in half again. Okay, it's similar to the idea you would do for 1 foot, right? 12 inch. You cut the 12 inch in half. So 6 inch, 6 inch will be half a foot, right? You do the same thing, okay? So don't be scared. You just need to get used to this new unit, right? So remember 180 degree is half a circle, 360 degree, right? 2 pi is a full circle, right? Let's keep cutting. Next one, I want to cut half a pizza into this. So we get little slice. Okay, how many degree is this picture now? Marcus?
Like 40, 45, 45.
No. You compare this picture with a 180 degree, right? 180 degree is half a circle. I split the half circle into how many pieces?
3.
Yeah. So how big is each piece?
30.
Huh?
Wait. Oh, how big is each piece?
Yeah. How many degree is each one?
Is it 30?
You need to split into 3. Half a circle is 180.
Oh, half a circle. Oh, sorry. Uh,
I'm asking this one.
oh, 60.
60 each, right?
Yeah.
Okay. So you have 60 degree. So for the radian, Marcus, it's still you. Radian will be what?
I don't know. Wait, is this pi over
Look
3?
at the half circle, okay? Half circle is like the starting place.
Yeah. Is it pi over 3?
Yeah, you do the same thing, okay? 180 degree divided by 3, so your pi also divide by 3.
Okay.
So pi over 3, it means 60 degree. It means a third of a half circle, okay? Okay, next one we're gonna do is, we'll keep cutting, okay? I think we should shrink it, huh? Not enough space here. Okay. Just 2 more. We only have 2 more. Right, so the next one I'm going to cut is cutting this way. This is half a circle, right? I cut in half again and cut each one in half. So you got 4 slices. How big is this shaded angle in degree? Okay, Caleb, how many degree?
Um, 30 degrees,
Nope,
20 degrees.
nope, keep guessing.
Um,
Are you guessing? Are you guessing?
give me a second.
Don't guess, okay? Think about how it compare with half a circle, okay?
Give me a second.
Yeah, I can
Um,
give you a minute.
45 degrees,
How did you find that?
180 divided by 4.
Very good. Cut into 4 slices, right? So
Mhm.
what would that be in radian now?
Pi over 4.
Yes. Okay. So if you just think about the number of slices of a pizza, okay? Last one we're gonna do is cut the half a circle into
Jason,
side. Yes.
I have a question.
Yeah.
What do you do if you can't fit?
If you cannot fit,
Yeah.
then you can write it on the at the bottom here. You can write it here. You have little space there, right?
Sure.
Yeah. Okay. Find a little space, or you can write it on the side. Okay. You should. Yeah. All right. So last part, you have this one. How big is that one in degree now? Now, Chris.
30 degrees.
Yeah. 30 degree. And what would that be in radian? Still you, Chris.
Pi over 6.
Pi over 6. Okay, we cut it into 6 pieces. Okay, 180 divided by 6 is 30 degree. So pi divided by 6 is 30 degree. Okay, so it all starts with a half a circle. These are the common ones. Okay, common angles. So you need to memorize them. Okay, but I don't like to memorize. You just remember the half a circle is pi. Okay. Any questions so far? So this is the conversion rule. Okay, we have 180 degree is pi, and then using that you can get everything else. Okay, so please raise your hand after you copy everything here. We have other rules, okay, which we'll go over next time. But first, we'll do this one, okay? Please raise your hand if you got everything on the screen. And then we're just gonna spend a couple more minutes, okay, to do the practice so you can do the homework, okay? All right, Caleb, Eric, and Marcus, have you finished writing down?
Oh, I'm almost done writing.
Okay. All right, so let's try the question at the bottom, okay? We're gonna do question A first. So 30, 45, 60, 90, those are the common ones, right? So just think about the half a circle. Okay, 30 degree, right? You need to cut a half circle into 6 slices, so pi over 6. Okay, so complete these ones first. Okay, when you finish the first 4, okay, please raise your hand. 30, 45, 60, and 90. And we'll talk about how to do the other one, okay? So just remember, over 6 is the 30 degree. All right, lady, what's 45 degree?
It's pi over 4.
Yeah, okay. Evan, 60 degree.
Pi over 3.
Yeah. Philip, 90 degree.
Pi over 2.
Yes, okay, so these are the common one. So we're gonna use these to help us get other ones, okay? So you have to remember, over 6 is 30, over 4 is 45, over 3 is 60 degree, over 2 is 90. Now suppose I want to get a 120 degree, okay? The next question. And you think about 120 degree is a multiple of which of the 4? Okay, so Caleb, 120 degree is a multiple of which one?
A multiple of 60.
Okay, how many 60?
2.
2 of them, right? So it's like you have 2 slices of the 60 degree. So that makes the radian same thing, you double it. It'll be 2 of the pi over 3. Okay?
Okay.
Pi over 3 is 60. You want 2 of them. So 2 pi over 3. So same thing, you can figure out the other ones. Okay, so please find out the other 3 answers and raise your hand. Okay. Just find out the multiples. Okay, 135 is the multiple of which one? 150, which one? Okay, 300, which one? Okay, does anyone have questions? Find the multiples. Is there anyone doesn't know what to do with 135 degree? Okay, so Nick, for 135, it's a multiple of,
Wait, so 90 degrees plus 45 degrees.
which one?
Like 135 degrees, it's like 90 degrees plus 45 degrees, right?
You could do plus, okay, but it's slower because you need to add fraction, okay? Just think about multiple. 135 is the multiple of which one of the
So 90 times 1.5.
Say that again.
90 degrees times 1.5.
No decimals. Is there the exact multiples?
Oh, so 45 times 3.
Yes, very good. Okay, that's faster, right? You have three
Yeah.
slices of 45. So each 45 is power 4. You want 3 of them. So you just put 3 pi over 4. Okay, so always match with one of the 30, 45, 60, and 90. Okay. Right, next one, 150 degree. Jenny, is a multiple of which one?
30,
Okay, how many?
5 of them.
So the radian will be
5 pi over 6.
yes. Okay, got it. Anyone else have questions? How to get the radian? Okay, Marcus, can you try the 300? 300 degree is multiple of
It's not 90, right?
no.
I don't know.
You understand how we get the other ones?
Yeah, they're multiples of like 45 and 60 and all that.
Yeah. So 300 degree is a multiple of which one of them?
30,
Okay, how many?
10,
Sure, you could do that. Or is there another choice? Another bigger one?
60,
How many?
5.
Yeah, so we can do either one, but we would choose the one that's the bigger because it makes the number of multiple less. Okay, so we can just do 5 60s. So 5 times pi over 3. Okay, if you use the 30 degrees, the same thing. Okay, you said 10 of them, right? So 10 power 6, but then you can reduce. You still get the same thing. Okay, if you choose the 60 degree, you don't need to reduce. Okay, any questions? So the bottom part, the next part, we need to do one more, okay? The bottom part, now you are more familiar with the radian, okay? So going backwards will be easy. So for example, you look at the first one, you have 11 power 3. So now you see the denominator is over 3. So that's got to do with 60 degree, right? Pi over 3, and you have 11 slices. Okay, pi over 3 is a 60, so you have 11 of them. So you have 11 times 60 degree. So that's 660 degree. So you just look at the denominator, then you will figure out how many slices of that you have. Okay, can you raise your hand if you understand how this works? Okay, how to get a 660? Okay, so you look at the denominator, right? If it's a 4, has to do with 45, right? If it's a 3, it's a 60 degree. If it's a 6, it's a 30 degree. Okay, Angela, Caleb, and Eric, Jocelyn, any question how to get a 660? Okay, so just find a multiple, right? If you have 5 pieces, you times it by 5. So finish this chart and raise your hand. If the question has a negative, so your angle will be negative degree, okay? Okay, we'll check the next one. CZ, what's the next one?
225 degrees.
How did you find that?
5 times 45 degrees.
Yeah, very good. And Claire, next one.
300 degrees.
And how did you get it?
I got it from multiplying 5 to 60 degrees.
Yeah, the pi over 3 is a 60 degree. Okay, Eric, next one.
I got negative 390 degrees because I got a negative 13 times 30 degrees.
Yeah, very good. Angela, next one.
270
Mm-hmm.
degrees because 3 times 90.
Okay. And Yosher, next one.
Negative 315.
Mm-hmm. And Nick, next one.
210 degrees.
Okay. We have last one, Marcus.
I didn't get it. Yeah.
Well, we can go over this one together, right? What's in the denominator?
3.
So got to do with pi over 3, right?
Yeah.
Okay, so how many degree is pi over 3?
60.
And will you need
Oh,
how
wait.
much?
60 times 4. Would it be?
What's that?
240.
Yes. Okay, that's how you do it, right? 4 times 60. So you need to remember the common ones, okay, to do these questions. Okay, let me just quickly check the homework. Am I still missing any of the homework? Eric, I don't have yours. You need to click submit. Eric.
I need to take a picture of the other one still, but I don't have it right now. So I'm gonna take it after class.
Oh, can you do it now?
Okay.
Yeah, okay. And then Evan, can you click submit? It's still not handed in yet.
Oh, I thought I handed it in. All right.
It's not there. You didn't click turn in. And okay, Marcus, I don't have your homework.
Yeah, I got one question to do.
Okay, and Jenny.
Okay, I'll stay after class.
Yeah, okay. And Jocelyn. Okay, so the rest of you, okay, if you don't have questions, you can leave the class, and I'll see you guys next week. Okay, I'll post the homework later. Okay.
Thank you, Jason.
Bye, Jason.
Welcome.
Thank you.
Bye bye. You're welcome. Have a good weekend.